It's good to see you again. We're on to day 2 of our practice final. We're going to go through problems 6 through 10 today. So here we go. Number 6. What are the zeros of the polynomial function? Some helpful clues for you there to help you get started. Read through them. All right. So zeros are also known as roots, x-intercepts, or solutions. So make sure you're familiar with those terminologies. Now, how many terms do we have here? I see 1, 2, 3, and 4. So we should be thinking factor by grouping, and that's exactly what we're going to do. So factor by grouping, remember, means you take the first two terms, you group those together, and you factor out a GCF. So here we go. We take that term, we factor out the GCF. Then we ask ourselves, what would x squared have to be multiplied by to get x cubed and to get negative 2x squared? Well, it'd have to be x minus 2. Same thing with the second group. Over here, we're going to group these together, factor out that GCF, which is negative 16. But the very key essential part to factoring by grouping is you need what's inside the parentheses to be exactly the same. If it's not, this isn't going to work. Because the idea is x squared wants to multiply with x minus 2, but so does negative 16. So if that's the case, why not just rewrite it like this, where we know we're going to have to multiply everything here with everything there, which also gives us some nice factors in parentheses that we can set equal to 0 and solve for. Now, hopefully you notice that this is also another pattern, the difference of squares. You could use that pattern to factor that further. Or in this case, you can just use inverse operations, which I did, add 16, square root both sides, and notice there is a plus or minus, so that means there are two solutions there. There's going to be a negative 4 and also a positive 4, and over here we set this factor equal to 0, x minus 2, so we also have the answer of 2, and that's a good sign because remember, the highest power of your polynomial, which in this case is 3, tells you how many solutions or zeros you will have. Number 7, what's the simplest radical form of the expression? I stress that because so many students forget to fully simplify, or maybe they just don't remember how. There are helpful tips for you on the right side. Read through them, use them. They're there to help you. The number one step is getting this into radical form. So you know you're going to have a radical sign, and then we follow the saying, dive in, no problem, where the denominator becomes the index. So the denominator, 4, becomes the index, which is that little number up in the corner there. And then no problem, that stands for numerator and power. The numerator becomes the power. The power of what, you might ask? Well, it's the power of this, because remember, the base stays the same. But it'd be nice if something else was there, wouldn't it? To kind of make this less confusing. And that's going to be parentheses. Now, we need to know our rules of exponents. In this case, the power to a power rule, which says if I have a to the 5th being raised to the 3rd, I need to multiply 5 and 3. That's exactly what we do. And then same thing, b cubed to the 3rd, that's b to the 9th, 3 times 3. If you said or thought that, hey, A was the answer, that means you have prematurely guessed at the answer without truly remembering the way to simplify all the way. Here's what you always need to ask yourselves with radicals. Is any power in the radicand bigger than the index? Because the index, in this case 4, is the gatekeeper. He or she decides who gets to go outside and who has to stay in. Okay? So the easiest way to simplify this is to divide. So we take 15 divided by 4, okay? And that gives us a 3 with the remainder 3. What this means is we're going to have 3 a to the fourth, and then the remainder tells us what that power is going to be of the last a. It's going to be a to the third. So we're going to have 3a to the fourth and 1a cubed. And you see that here? I wrote them all out. 3a to the fourth, 1a cubed. Same thing with b to the ninth, because that exponent is bigger than the index. 9 divided by 4, 2 remainder 1. So 2b to the fourth and 1b to the first, because the remainder was 1. B to the first, we still see that right there. And remember, if the index matches the power, you only take 1 out. It's just like taking the square root of, I don't know, let's just say x squared. If you don't see an index, there's an invisible 2, right? Anytime you hear square, you should think 2, square root, squaring, okay? But those are inverses, right? They cancel each other out, so you would only take out 1x. So the answer there would just be x. Same idea here. If the index of 4 matches the power, you only take out 1a. Now, we're only taking out 1 at a time, but look here, we're taking actually 1, 2, 3 out, and the a to the third has to stay. Okay, and what do we do with these 3 a's? You multiply them together to give you a to the third, and then you have your b's. So you take out 2 b's, b times b is b squared. Okay, and I'm noticing one mistake. This index should actually be 4. There we go. And what's left? We have a cubed trapped and b to the first, which we can just write as b. So there's our final answer. Just making sure there's nothing missing, and there is not. So let's move along to number 8. Solve for x. We have an inequality sign here. We have an x here and an x there. We want to get those x's together. This one is trapped inside of a parenthesis, so I would want to handle that first, I would say. That's the first goal. Get that x out of there. Let's see how you did. The answer is C. Okay? Now, you could have picked different numbers to multiply everything by, but 12 is a good choice because it's going to get rid of most of these fractions, just not the 5/3, because that's in parentheses. So if you multiply everything times 12, this is the same as 12 over 1. 4 goes into 4 once and 12 3 times. That's why we get the 3 right there. And what else? Well, here we have again 12 over 1 times, where are we? Where are we? Here we are, times 1 over 12. Well, that's just equal to 1, right? You get 12 over 12. So we see that 1 right there. And what's left? Well, these are just regular terms, no fractions. So multiply them both by 12, and there we are. Okay? So we did some good work. We got rid of this fraction and this fraction, making our lives easier. And now it's time to move on to the next step. So looking here, what do we have? What do we want to do? I would say multiply, because again, we need this x out of those parentheses. So we multiply here and there. And this is what we get. Look at that. The 3's cancel out. No more fractions. Very nice. And what do we have? Well, we have all these guys just hanging out, being patient, but they're about to come into the mix because there's no more fractions, no more parentheses. So now it's just time to combine like terms. So here we go. We're going to do that here. We're going to pick a side that you want the x's to be on. Okay? I just so happen to want them on the left. So I subtract 36x on both sides. And I know I want all my constant terms on the right. So I also, at the same time, subtract 6 on both sides. So that's exactly what I get. X terms on the left, which now thankfully is just one x term. Constants on the right. Notice the inequality sign did not flip. Do you remember when it flips? Well, it says right here, anytime you multiply or divide both sides by a negative, you're going to flip that inequality. Didn't happen here, but let's just prepare you for any situation. It's saying by a negative. By is the key word because if this was negative, you're dividing 6 by negative 18, right? Then you would flip things, flip that inequality. But if this 6 was negative, are you dividing by a negative? No, you're dividing by a positive 18. So that's the difference. Now, 6 goes into 18 3 times, so you get x is less than 1/3. Three down, 2 to go. You got this. Let's do it. If my mouse will scroll, there we go. Answer the following questions and draw a rough sketch of the function. Lots of terms here. 1, 2, 3, 4, 5 terms. You've learned how to do this. There's actually a handout in the recordings document about this. Maybe you've printed it out. Maybe you can find it now. But we want to know the general shape and which way it faces and so on. You can read through these and give yourself a chance to practice right now. So what's the deal? Well, the leading term has an exponent of 4 right here. So we know the general shape is a W, okay? And I know this isn't a graph we see all the time, but we've learned about this before. So just, if you don't remember, write it down now. If the leading power is 4, the general shape is a W, but the leading term is also a negative. So that means it's going to open down. That means the arrows are pointing down, so it's flipped upside down. Kind of looks like an M. Now, what's the function's y-intercept? Well, if x was a 0, just think about what would happen. You don't even need to show the work. All of this would multiply times 0, so the only thing left would be negative 144. So that's our y-intercept. And our last question here, if one of the factors is x minus 6, how would you show that on a graph? Well, that's not too difficult. All you do is set it equal to 0 and solve for x. So that tells you if this is a factor, then an x-intercept is what you get when you solve for x. In this case, the x value of 6, y value of 0, because it's on that x-axis. Okay, last problem for the day. Which graph represents the solution to the system of equations? There may be something you need to do first. And I put that on the board for you, so make sure you read the helpful clues before you try this. If you said B, you were correct. Let's see why it's B. Like I mentioned here, hopefully you read this and used it to your advantage. You need to get both of these in slope-intercept form. Okay, the first thing you should notice is, okay, these are inequalities. I have x to the first, y to the first, y to the first, x to the first. So these are both linear inequalities. So we're going to have two straight lines, and I know they could be solid or dashed. I know because this has an underline, it will be solid. Because this does not, it'll be dashed. Again, remember, underline means solid line because the points on that line make the inequality true. If you pick those x and y values, you substitute them in here, it will give you a true statement. Dashed line means points on the line are not. So if you plug those in here, this will not give you a true statement. It'll say something like 0 is greater than 5, right? We all know that's not true. Now that we cleared that up, we need it in y equals mx plus b. I know it's not an equal sign, but it still follows those rules. So you take this inequality, you subtract x on both sides. Now it's in slope-intercept form. And for your notes, I would suggest writing this down. Just saying A, B, C, or D is not going to be enough to get credit for this because it's really not going to help you. I already talked about the underline. Now we know this is negative x, so there's a negative slope, but negative what? Well, if you don't see a number, it's always 1. So we have negative 1. But slope is rise over run. How would you write that as a fraction? Well, negative 1 over 1, right? You can put any number over 1, and it stays the same. So that means rise over run, so that means down. Down is negative, and run right is positive. And the y-intercept is 7. So we're looking for the y-intercepts of 7. We see them here, 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 here. And if you look closely, you'll actually see that all of these lines are in the exact same position. But I'm going to go through this in detail still, so you're prepared for any situation. Okay, so all of them have a y-intercept of 7. We know they all have a negative slope of negative 1 over 1, so down 1. Let me zoom in so I can see a little better. Yeah, that's at 7, so it's going to go down 1, right 1, down 1, right 1, down 1, right 1. Notice they're a little more squished in on this axis where they're not on that, so you just got to pay close attention to that, but they are all graphed with that slope. Okay? And it should be solid because there's this or equal to. So this line, this top line must be solid and it is in all situations. Okay, that's not really helping us, but let's see if there's something else. This is also saying less than. So it should be graphed below. So it should be shaded below. Is this shaded below? Is this shaded below? Yeah, it is. It is shaded below, right? Just because this little corner pocket right here, you can see if you extended this line up, it's not shaded above there. Okay, so A, it's shaded below. B, it's clearly shaded below. C, no. You do not see any shading below this line. So right now, C is out. D, same deal. You do not see any shading below, so it's between A and B. So we need to look at this inequality now, which thankfully is already in slope-intercept form. So we look for the y-intercept of 2. Just as we mentioned before, all these lines are in the same place, but just to be clear, slope of negative 4 or negative 4 over 1, so that means down 4, right 1. So we start at 2, so we're going to go down to negative 2, right 1. There's another point, and we're just going to, you could keep doing that as many times as you need to. What was it? Down 4, so down to negative 6, right 2, or right 1, sorry. and so on. Okay, but what's happening here? It's greater than, so that means we should be shading above. So right here, B is the only graph, I show it with these arrows here, where you see the shading trapped beneath the top line and above the bottom. So we made it through 10 questions. Remember, the final review, there are 25 practice questions because there's 25 on the final, but we're taking it one problem and one day at a time. I'll see you next time. Happy studying.